So welcome guys, this is Rakshith. I am going to teach you microprocessor. So in GATE syllabus there are only 3 topics for microprocessor. They are architecture, programming and memory and I/O interfacing. So this is the easiest subject of GATE syllabus guys. If you check previous year GATE questions, there are questions only on programming and memory and I/O interfacing. But to understand this we need architecture. So let us proceed with the architecture. So this is the simple block diagram of 8085 guys. This is our microprocessor, which is connected to input devices and output devices and memory. See, 8085 microprocessor will not have any internal memory. The memory which we are connecting is the external memory. So in 8085 microprocessor, we will have arithmetic and logical unit to perform the operations, and you will have control unit to control what operations are performed, and you will have registers. So these are the things which we are having inside the 8085 microprocessor. While coming outside, it is interfaced with input device, output device and memory. See guys, it can only take data from input device and it can only send data to output device. It cannot send data to input device and it cannot take data from output device. So this is unidirectional. While here, it can give data to memory or it can take data from memory. So this is bidirectional. So guys, first thing is, for giving or taking data, we need a data bus. Next thing is, it should know from which location data should be taken. That location is called as address. To point that address, we need an address bus. Next, after getting address of the location, we should know whether to take the data from the address or to write the data into the address. For that, we need a control bus. So what are the 3 types of buses guys? Data bus, address bus and control bus. So if you see this guys, this is our microprocessor, this is the memory. So what will microprocessor do is, it will send the address to the memory. At that address, which data is there, that data it will take. This is the first operation. Second operation is, it will send the address to the memory. At that address, it will write data. That is the second operation. What is the first operation guys? Read data. What is the second operation guys? Write data. Read data from memory. Write data into memory. So if you observe here, 8085 can only send address to the memory. Memory cannot send address to the 8085. So address bus is unidirectional. It should send address, and whether to read the data or write the data in that address depends upon the instruction we give. But if you come to data bus, it can read the data from memory. So reading the data, or it can write the data into the memory, writing the data. So data bus is bidirectional. While address bus, it can only send the address. And at that address, what is the operation depends on our programming. So this is the basic idea guys. Address bus is unidirectional. At that address, whether data should be read or write. So data bus is bidirectional. While coming to address bus guys, so address bus has 16 lines. So don't ask me why it is having 16 lines. Intel manufactured the address bus like that. We are learning already manufactured microprocessor. So it is manufactured already. We are learning that manufactured microprocessor. So it manufactured address bus with 16 lines. So what it can do? It can send a 16-bit address. So 16-bit address means 00002 F, 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 F. Friends, don't think this is a 4-bit. It is 16-bit. F means, so it can send 16-bit address. So indirectly it indicates that, see guys, if you have only 2 lines, how many addresses you can send? 0, 0, 0, 1, 1, 0, 1, 1. You have this many addresses. That means 2 square. If you have 3 lines, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. This many addresses you can send. That is 8. Indirectly 2 cube. But here you are having 16 lines. So how many addresses you can send? 2 power 16. This many addresses you can send. So 8085 is having 2 power 16 addresses. If you check here, let this be 0, 0, 0, 0. Let this be 0, 0, 0, 1. And I'm considering the first 4 addresses, guys. So at each address data will be stored. Address is of 16-bit, but data which is storing inside the address, it is of 8-bit. It is of 8-bit. So it is having 2 power 16 addresses, but at each address some data is stored. The data is of 8-bit. Similarly, here also 8-bit data is stored. Here also 8-bit data is stored. So up to 2 power 16 addresses, at each address 8 bits data is stored. Not 8-bit data is stored. 8-bit data can be stored. Whether it is stored or not depends upon our program. So data bus is of 8 line. Why 8 line, guys? It should send only 8 bit of data. Because Intel manufactured the data bus as 8 line, it can only send 8 bit of data. So at each address we can store 8 bit of data. If you see the memory of the total 8085, see there are total 2 power 16 address lines. At each address you can store 8 bit of data. So it is the total memory of 8085. But you know guys, 8 bit is equal to 1 byte. So consider this as 1 byte. So what will happen? 2 power 16 bytes of memory. 2 power 16 can be written as 2 power 10 into 2 power 6. 2 power 10 is nothing but kilo. 2 power 6 is 64. So it is having 64 kilobyte of memory. Is this okay, guys? So if in a question, if we use number of address lines and number of data lines, you can calculate the total memory. See if m is the number of address lines. If n is the number of data lines. What does that indicate, guys? There are total 2 power m addresses. In each address, n bit of data is storing. So 2 power m into n bits is the total address. If we ask in byte, divide by 8 byte. So now we know how to calculate the total memory, guys. So we read about address bus, we read about data bus. Now at starting, I said you something, that is we should give address to the memory. Whether to read the data or write the data depends upon our program. So whether reading the data or writing the data, the control bus will give the information. Whether to read the data or write the data, control bus will give the information. So what does address bus will do? It will points the address. What does data bus will do? It will either send the data into that address or take the data from that address depending upon the instruction given by the control bus. Read the data or write the data. So this is the basic idea of the microprocessor, guys. Guys, if you look into this memory consists of RAM, ROM, and input output devices, guys. So with the 16 lines, it should address this many devices: RAM, ROM, and input output devices. So if you see this, guys, I am separating the memory. In the previous diagram, I have shown memory, input devices, and output devices in the same box. Now I am separating the memory, input device, and output device. So now our memory consists of only RAM or ROM. So what I said is 8085 will generate address. At that address, whether to read the data or write the data will depends upon the control signal generated. So guys, see, 8085 can take the data from the input device, or can write the data into output device, or it can send the data into memory, or it can take the data into memory. So which operation is performed will depend upon our control signal. So for read control signal, our control bus generate active low read. For write control signal, our control bus generate active low write. And this is input output device, this is memory. Whether to read write from the memory or read write from the input output devices. So these are the signals our control bus generate. So we'll start now, guys. I want to read from input. So what is the signal I will generate? Read will be 0, write will be 1. Because I want to read, so I am writing read as 0. Why 0? Guys, if it is like this, if it is 1, it will be in on state. But if it is RD bar, if it is 0, it will be in on state. I hope you know this difference. It is active low signal. So since it is a read operation, I am taking it as 0. We don't want write, so I am taking it as 1. And I want read from input device. So I need this. I will take the signal as 1. If I take 0, memory gets selected. If I take 1, input output devices get selected. So from input output devices, I need read operation. So read operation is only done by input device. That's it, guys. Now I want write operation to output device. So what I will select? My read signal will be 0. My write signal will be, my read signal will be 1 because I need write operation, right? So it will be 0 to output device. So this will be 1. Now I need operation of read from memory. So I need this operation now. What will be RD bar? 0. What will be WR bar? 1. And IO memory. What will be this? 0. Because I need from memory. Memory is active low signal. So guys, now you write this code for write to memory. So RD bar will be 1. WR will be 0. And this will be 0 because I need write operation. So this will be 0 and this will be 1. Write operation to memory. So it points to 0. So these are the signals generated by control bus. By using this signal and by using the address and by using the data from the data bus, the microprocessor will perform the operations. So hope guys you got a clear idea on 8085 microprocessor, right? Now what I will do is I will show you the complete block diagram and I will explain. Before going to block diagram, guys, here I am telling memory read write operation. So if you check the memory, guys, you will have two kinds of memory. First one is RAM, another one is ROM. It is read only memory. From the ROM we can only read the data. So only memory read operation is possible from the ROM. While coming to the RAM, we can either read the data or write the data. So here memory read write operation is possible. So remember this. From ROM you can only read the data. Only memory read operation is possible. But from the RAM either you can read the data or write the data. So memory read write operation is possible. So this is the total architecture of 8085 guys. If you observe here, don't see all this. I will explain one by one. You will get whole idea. See, first what it will do is it will send an address to the memory. See, before explaining this, I will tell you one thing. I said you that address bus is of 16 lines. So from A0 to A7 and from A8 to 815. So this is the 16-bit address line. Next, I also said that data bit is of 8-bit. Data is of 8-bit, so it will have 8 lines. So what Intel did is, it multiplexed the data lines with address lines. So these lines not only sends address, they will also send data. D0 to D7. See, from A0 to A7, they are not only address lines, they are also data lines. Why? Why means Intel manufactured it like that. From A8 to A15, they are only address lines. So it is 16-bit address and it is 8-bit data. Data is sent through address lines only. So from A0 to A7, address lines and data lines both are same. But from A8 to A15, they are only address lines. So this is the 16-bit address. This is the 8-bit data. Next, if you see here, microprocessor will send the address to a memory. So whatever the instruction is there in the memory, suppose the instruction is add B. So with what should we add B? It indirectly indicates that there will be accumulator guys. So add B with accumulator and store the data in the accumulator. Accumulator is nothing but a register. So this instruction indicates this thing. Add B. So B should be added with the data present in the accumulator and the data is stored again in the accumulator. So for any operation, accumulator will be there. For any operation, either for subtraction operation, addition operation, we need two registers guys. Say if you want to add two numbers, you need two registers. In that one will be accumulator. This is fixed. Why it is fixed? Intel manufacture like that. So for any operation, one register is accumulator. That is fixed. Second register is our wish. Add B, add C, add D. That is our wish. If we write add B, the data which is present in the add B is sent to the temporary register. So what is the meaning of add B instruction? Data which is present in the B should be added with accumulator and the data is stored in the accumulator. So in accumulator already data is there. The data which is present in the B register is sent through the internal bus to the temporary register. So what ALU will do is it will add this temporary register data with accumulator data and it will store the result back in the accumulator. So this is the thing what is happening. So if you see here guys, these are our registers. So we are having A, B, C, D, E, H, L. These are our register guys. A is used as accumulator. B, C, D, E, H, L. Since data is stored in the register, everything is 8-bit. We already discussed that data is 8-bit in 8085. So everything is 8-bit here. All are 8-bit registers. If you see stack pointer and program counter, what is the function of program counter is it will store the address of next instruction. So since it is storing the address, program counter is of 16-bit. Next, what SP will do is, SP is stack pointer. It will store the address of top location of stack. So I will explain you in detail everything, guys. Since it is storing the address, it is also 16-bit. Next, since B is 8-bit and C is 8-bit, if you want to use this as 16-bit, you can combine BC, or you can combine DE, or you can combine HL if you want to use this as 16-bit. But you should not combine BD, BE as your wish. You should not combine. There are only 3 pairs possible, that are BC, DE and HL. Next, so you are seeing WZ also here, but guys, this WZ registers are not accessible to users. These W and Z are used by this microprocessor for its internal purposes. Similarly, this temporary register, this is also not accessible to user. So this WZ and temporary register are not accessible to user. Microprocessor will use that for internal purposes. So BC, DE, HL, each one is 8-bit. If you want a 16-bit, you can combine BC pair, DE pair, HL pair. And SP will show the top location of the stack, address of this top location of the stack. So it is a 16-bit. And PC will show the program counter, address of next instruction. So it is also 16-bit. Next, this is increment decrement operator, guys. So if you see the control unit, timing and control unit, read operation, write operation, and input output and memory operation. So hold, reset, clock, ready, these are normal things, guys. So there are 2 status parts, S0 and S1. These S0 and S1 will show which operation is performing, whether it is a read operation or write operation. So if S0 and S1 is 0, 0, halt, no operation is performing. If S0 is low and S1 is high, it is write operation, guys. So you should remove it. You should remember it. There is no logic here. If S0 is high, S1 is low, it is read operation. If S0 is high, S1 is high, it is fetching operation. What is fetching, guys? Taking instruction from the memory. It is called as fetching. So it will not participate in any operation, guys. It just shows the status of which operation is performing. It won't participate in any operation. Similarly, if you check the ALU here, ALU is having the flag register. So what is the operation of flag register is, it shows the properties of the result. If we gave a instruction add B, so A is added with B and result is stored in A. So what will flag register do is, flag register will show the properties of the result stored in A, whether it is having carry, whether it is 0, about its parity, about its auxiliary carry. So it will show the properties of the result stored in A. It will also not participate in any operation. It just shows the status. So what kind of result we got? Similarly, sign also. What kind of result we got, whether it is a positive result or negative result, whether it is a 0 result or non-zero result, whether it is even parity or odd parity, whether it is having carry, whether it is having auxiliary carry or not. So these all status of the result is shown by the flag registers. So here there is interrupt control, guys. About this I will discuss at the last, because it is not that much important and just 2 minutes topic. I will discuss at the last. So this is the architecture of 8085, guys. To understand programming, this much knowledge of architecture is enough. What is PC, what is SP, what are the registers, if you want 16-bit, how to combine the register, what will accumulator do, what will add by instruction will do, accumulator is the primary register, what will ALU do, what will flags indicate, and what is the read write control unit. So how many address buses will be there, how many address lines will be there, how many data lines will be there. So this much information is required to understand programming. So I'm ending with this, guys. In the next lecture we will start programming. So if you like my explanation, do subscribe to my channel, guys. And if you like this video, press the like button. That's for now. Thank you.